More than once, you've caught yourself wondering what will happen in the future, in 100, 1,000, or even in 1,000,000 years. And for you, we tried to look behind the screen of the future through the evolution of the stars we see in the sky every night to absolute oblivion. Today, we'll try to tame time and find out what our universe will look like in 100 million years. Check your seatbelts. In a few seconds, you'll find yourself at the very beginning of the universe's life and travel all the way to its last moments. We're about to begin. Of course, nothing in our universe can exist forever. In 100 million years, all the massive stars that we see every night will disappear, leaving only fields of nebula. Stars start out as large molecular clouds of gas and dust. They evolve over tens of millions of years and then remain shining in space for millions or billions of years. Stars in particular, although they hardly change during their lifetime, eventually, due to the synthesis of hydrogen to form helium, their temperature and brightness decrease and their core shrinks. The death stage begins, lasting slightly less than their actual life. Then stars with a mass close to the Sun in about 9 to 10 billion years become red giants. And after billions more years, they completely fade away, leaving behind only remnants in the form of white dwarfs and a plume of gas and dust from which new stars are born. However, the period of 100 million years will also affect our Sun. It will become brighter and warmer by 1%. In 1 to 2 billion years, the Sun will heat up to a point that's fatal. But what if this process could be slowed down? Still, a period of 100 million years is incredibly long for humanity. During this time, our science will be able to reach a level that may seem like science fiction to us now. In 100 million years, we'll probably be able to tame the stars and determine how much longer they'll shine thanks to stellar engineering. During this period of time, humanity will hypothetically be able to replenish the star's fuel reserves or artificially influence its nuclear reactions. Then, the Sun could survive longer and not threaten life on the planet. Manipulation of stars is also likely to create conditions for the development of life on planets that are not currently considered habitable. In particular, the humanity of the future will be able to extract hydrogen and helium from stars for energy production. Human civilization will grow to an incredible scale, so the resources offered by the planets alone may not be enough to supply energy to such a large number of people. Furthermore, fuel extraction using the theoretical Dyson sphere, which would harvest stellar energy in close proximity to a star, would preserve resources and the environment on the planets where people would hypothetically live. On the other hand, what if stellar engineering allows us to accelerate their aging by collecting fuel? In this case, life near these stars will be dangerous, and the galaxies in which these stars are located will begin to age rapidly. Yes, not only stars are affected by the passage of time, galaxies, and in particular the one we live in, appeared at the beginning of the formation of the universe and continues to move towards oblivion. However, before they die, galaxies, like stars, will go through a long way of evolution, but by merging with others. Over a long period, smaller galaxies will become part of larger ones. So in 100 million years, the number of small galaxies will likely decrease, as well as the mixture of spiral and elliptical galaxies will increase slightly. The humanity of the future will see repeated examples of galaxy mergers, especially with small galaxies, which can lead to the formation of new structures, such as wave tails and, in particular, supermassive black holes. The Milky Way is also moving towards another galaxy, Andromeda. Although we shouldn't worry, even in millions of years, their collision would take place in about 5 billion years. In 100 million years, our galaxy will have traveled about 978,000 light years, although this will not affect us in any way. After the same amount of time, the galaxies will change their location, moving to areas with different densities that will affect their morphology and star formation in different ways. But in the future, bright, beautiful galaxies will also fade away. The reason for this is the death of stars, especially massive ones, which determine the color and brightness of galaxies. After the last explosion of a star, most of its gas will remain inside the galaxy, keeping it alive, but some of it will leave the galaxy. Because of this, fewer large stars are formed. The mass of the galaxy suffers, and in millions of years there'll probably only be a black hole in its place. In fact, it is impossible to find anything static in our universe. Absolutely everything is in motion, including perhaps the universe itself. From the very beginning, the Big Bang, the universe has never stopped expanding. In the early stages of the hot Big Bang phase, the universe expanded faster than light. Only after cooling down, when the energy density of matter became higher and protons, neutrons, and electrons were formed, did the speed slow down a bit. And in 5 billion years, it slowed down a lot. However, both now and in the future, the universe will not stop expanding. It should be understood that expansion does not mean that matter is moving, but that time itself is expanding. Like a balloon with 2 dots drawn on it. The more you inflate it, the further apart the dots will be. However, this hardly affects objects that are connected by gravity, like our galaxy and Andromeda, or even ourselves. The amount of ordinary and dark matter always remains constant. Only space and density of matter change due to its spread over a large volume. However, we can see that other galaxies are moving away from us. In 100 million years, the galaxies of the local group may be so far away that it will be a little harder for us to see them. While faraway clusters of galaxies like CL J1001 plus O220 will probably be almost invisible. However, the expansion of the universe is accelerating. The rate of expansion is 44 miles per hour, which means that every 3.26 million light years, the speed increases. This will not end well for the universe. In millions of years, it would be harder for cosmic bodies to form. The building blocks would fly apart too quickly. The main factor in this is dark energy, because hypothetically, it can counteract the gravity of matter. Dark energy is a hypothetical energy and a necessary property of time that can lead to inevitable consequences in the future. So in 100 million years, the expansion rate may increase so much that galaxies would stop merging and thus evolve. The mass of dust and gas that's ejected after the death of stars will be dispersed. Stars will form less often. Moreover, in billions of years, gas leakage may become too fast. In this case, absolutely nothing will be able to form. No stars, no galaxies, no life. The heat death will eventually come. The heat death is not related to the transformation of our universe into hell through the evolution of stars. The scenario of the future fate of the universe is based on the second law of thermodynamics, according to which, in a closed system, entropy, or the state of disorder, increases over time. That is, the energy will dissipate in such a way that absolutely nothing will be able to form into something unified. You can think of it as heat energy leaving your cup of tea and dissipating in the room. Eventually, the temperature of the tea becomes the same as the room, so you can no longer get warm when you drink it. So the drink is not doing its job. So galaxies will be too far apart and stars will start to fade because there'll be no more necessary inflow of energy or matter for the evolution of stars, planets, or other space objects. The universe will become completely dark and empty. Dark energy may threaten not only heat death in the future. If the expansion becomes many times faster over the next 100 million years, then the universe can expect absolute death in the future. Stars will not just stop forming as in the previous scenario. Nothing will exist, not even fundamental particles. Since matter, such as stars, remain unchanged, they don't increase their mass through expansion. Then, when in a few billion years the expansion can become immeasurably fast, the stars will not withstand such an influx of energy and will simply explode. Another scenario for the end of our existence is the Big Rip. It suggests that since the acceleration of expansion probably cannot be influenced, in 200 billion years it will become so fast that gravitational interaction will be broken. Planets will leave their orbits, and subsequently the electromagnetic force that maintains the integrity of stars will not be able to resist dark energy. With even more time, even atoms will not be able to resist, and they'll be torn apart. Moreover, there's a possibility that after the Big Bang, everything in the universe will return to the first stages of the Big Bang. However, what will remain in the singularity will not look like the plasma that was at the beginning of the Big Bang itself. It'll be cold and dilute, as opposed to hot and dense. That is, no matter how terrible the hypothetical end of the universe may be, there is a chance that this end will be a new beginning. Another danger to the entire universe may be hidden in ourselves. We all know that everything around us is made of atoms. There are two elementary particles in the nucleus of an atom, a proton and a neutron. We also know that these particles are stable within the nucleus, meaning they cannot decay. But what if this is not necessarily true? The proton is one of the most common particles in the universe. It can exist even outside the nucleus. The proton has reasons to be stable, namely the laws of conservation of energy, charge, and baryon number. Although according to the standard model of physics, the proton cannot decay in any way. The latest theories, such as the theory of grand unification, which combines the three fundamental forces, electromagnetism, weak and strong interactions into one, allow it. So, in the distant future, there's a possibility that this particle will decay. This seemingly unlikely process is unlikely to cause disaster to the entire universe. But if it happens on a massive scale, then in millions or even billions of years, part of the universe will cease to exist. The proton decay will destabilize the nucleus of atoms and produce decay products that can affect the entire structure of the universe as matter begins to decay. But the whole world will not disappear. The entire system of galactic evolution in the regions where proton decay occurred would be disrupted. The people of the future can exhale. The protons in their bodies are likely to decay. But the 100 million year time frame may bring another threat in addition to the heat death and the Big Bang. If the collapse of protons is too large and strong, it will trigger an inevitable scenario of the terrible end of the universe, but not because of protons alone. The destruction of all matter in the universe, without even a hint of its former existence, is hypothetically possible through a bubble. You've probably heard of the Higgs boson, which is a fundamental component of the Higgs field, a theoretical field that permeates the entire universe, and to which particles gain mass when they interact with it. In addition, the Higgs field can affect the vacuum. We are used to thinking that a vacuum is an empty space, but there are quantum fields in it, so a vacuum simply contains as little energy as possible. So, the field determines whether the universe is in a true vacuum or a false vacuum. A true vacuum means the universe is stable and has the lowest possible vacuum energy state. A false vacuum, on the other hand, means the universe is metastable, meaning with a higher energy but less stability. According to modern theoretical data, our universe is metastable. This is precisely the threat to all future life and matter. If in 100 million years an event occurs in the universe that would have enormous energy, such as a massive proton decay, then a small particle of the universe will hypothetically be able to enter a state of true vacuum. Thus, a bubble of true vacuum will form, which would expand at the speed of light, destroying all matter and fundamental particles in its path. Life can hardly appear in any form after such an intervention. The universe as we know it will change over time and one day become completely unknown to us. It will continue to evolve, but like all of us, it will begin to fade away at some point. We don't know when this will happen. No matter how hard we try to look into the future, we'll never get an accurate prediction. One thing we can say for sure about the future is that humanity will see more than one outstanding discovery, which perhaps in 100 million years will reveal the full history of the universe and ourselves to the humanity of the future.